Number 9, they tell us that for this triangle within a triangle, that AB is equal to AC. So I'm going to do this off to the side in red. AB is the same length as AC. And I'm going to call them both a length of y. I'm going to use y instead of x because, well, later in the problem they tell me to use x for something else. So, they also tell me E is the midpoint of AB. So here's E. So AE is the same length of E as EB since E is the midpoint. But notice that it doesn't look that way. The picture they drew doesn't look that way either, but that's okay because they said the figure is not drawn to scale in the note. So, and they want us to say that AE is equal to x, which means EB is going to have to be a length of x as well since those segments are congruent. And what else? They tell us D is the midpoint of AC. So here, so this segment, AD, will be congruent to DC, which I put double tick marks on each of those. I use double tick marks so that I'm not trying to imply that all 4 of those segments were the same. Alright, so now what I'm looking for is the length of BC, which I'm going to label Z for the heck of it. And now what I have is a triangle within a triangle, and those triangles are similar, so I can set up a proportion. So I'm going to do this in blue. Oh, they also tell us ED is 4. Okay. So now AE is x, ED is 4. So x is to 4 as, and now I'm going to switch to green. Okay. So x is to 4 from the smaller triangle as AB, the side of the larger triangle, which is going to be 2x, is equal to the base of the larger triangle, which I called Z. And Z is what I'm looking for because Z is BC. Alright, so if I cross multiply this, xz is equal to 8x, divide both sides by x. The x's cancel on both sides, and so z is equal to 8, which is my segment that I'm looking for.